Alright, here we're going to find the exact trig values. Now, I'm going to do this, and I'm going to show you a way to kind of, if you memorize, or you learn some of the stuff, you don't have to memorize the whole thing. The good thing about trig is that we have patterns that repeat over and over again. So I'm going to start out by drawing me a coordinate plane. Okay, after I draw this, I'm going to draw three angles coming out of here. Now, we know it's on the unit circle, but I'm not really going to draw the circle. I'm just going to come up with the angle measurements because that's what we're concerned with at this point. Alright, so those are my three angles. Now, as I go around the circle, I know this is 0, this is pi over 2, this is pi, okay, this is 3/2 pi, and then we'll be back at 2 pi, and then we just keep going around and around. But for the first revolution, this is what we need. Now, as we go here, I know that this is pi over 6, this is pi over 4, and this is pi over 3. Now, what I'm going to do is come up with my x and y coordinates here. And I'm going to show you a way to kind of do this without having to memorize a bunch of stuff. And then we're going to take these and use them as reference angles for the other three quadrants. Alright, now I know pi over 3. Now what I'll do is I'm going to put in 2 in my denominator for each one of them. And then I'm going to count down going this way. So I'm going to go 1, 2, 3. 1, 2, 3. Then I'm going to go up. 1, 2, 3. Okay, now I have to take the square root of all the numerators. The square root of 1 is 1, so I'm just going to leave that alone. So we have the square root of 2, square root of 3. Then we do the square root of 1, square root of 2, and square root of 3. Okay, so now I have the information I need. Now also we could go ahead and put in our values for the quadrant angles too, but we'll talk about those as needed. So here we have sine of pi over 6. Remember that sine of theta is our y value. Okay, for this one, our sine is 1/2. Okay, we're in the first quadrant. Remember our other little thing that we came up with that all students take calculus. So everything's positive in the first quadrant. So for the answer to this is 1/2. So the sine of pi over 6 is 1/2. Alright, now here we're asked for secant. Secant's going to be a little bit more involved, but let's think about our relationships. Okay, secant of theta is the inverse of what? It's the inverse of cosine. Now, so cosine is what we need. Now, and we'll flip our cosine. So we'll get our reciprocal. Cosine is the x value. Alright, so let's go figure out what the x value is when we have a denominator of 6. Going back to our reference, when we have a denominator of 6, our x value is going to be the square root of 3 over 2. So for this one, we end up with square root of 3 over 2, but we don't want cosine, we want the secant. So we're going to flip this. We're going to do the reciprocal. So it's going to be 2 over the square root of 3. So the secant of 7 pi over 6 is 2 square root of 3. Now with this we got to decide if it's positive or negative. So we have to decide what quadrant are we in. Now I'm going to draw another little diagram right here that may help. Okay, remember this is 0, this is pi halves, which would be the same as 0.5 times pi. This is pi, which is going to be 1 times pi, so we end up with 1 there. Here we have 3/2 pi, so we have 0.5 times pi. All I did was convert the fractions to decimals if we're there. Alright, 7 over 6. If I divide 7 by 6, I end up with 1.16. But the more important thing is it's in this quadrant. Okay, so the 1.16 is between 1 and 1.5. So that's going to give us our sine. Remember, all students take. Okay, only tangent and cotangent are positive in this quadrant. So that means secant has to be negative. Now, one other word of warning right here, I would take this as an answer. I'm fine with that answer. But you may also see it rationalized. To rationalize it, we just multiply the top and the bottom by the square root of 3. So you may also see the answer is negative 2 square root of 3 over 3. So secant of 7 pi over 6 is equal to negative 2 square root of 3 over 3, or negative 2 square root of 3. Our book used the top one, but I want you to have seen this way as well. Alright, here we have cotangent. Now, this one is not, we can't use one of our reference angles. This is going to be on either the x or the y-axis. Remember, here we're going to be 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Now, pi halves is up here. Okay, now remember, tangent is going to be y over x. So that means cotangent is x over y. So our x value, now it may help to remember cosine and sine, but for this, our x value is 0, our y value is 1, because we get 0 over 1, which is going to be 0. So cotangent is 0 at pi halves. Okay, now with this one, this is one of our reference angles. So if we go back to where we did our reference angles, pi over 4, anytime you have 4, okay, and you're on the unit circle as a denominator, it's going to, the sine and cosine are going to be square root of 2 over 2. You just have to figure out which quadrant you're in. This right here is in the first quadrant, okay, because it's a reference angle. So cosine is just square root of 2 over 2. And we're done with that one. Alright, cosecant. Cosecant here, okay, remember cosecant is the inverse of sine. Okay, so sine goes with cosecant. And we know sine is equal to our y value. So we'll go 3 halves. Now 3 halves, again, we're not going to use a reference angle because we're going to be on either the x or the y-axis. Let's see. So we know that this is 1, 0, 0, 1, and then this would be negative 1, 0, and then 0 and negative 1. Okay, so we're down here. Now our y value is negative 1. So sine of theta is equal, well, not theta, sine of 3 pi over 2 is equal to negative 1. Well, the inverse of this is going to be negative 1 as well. So cosecant of 3 pi over 2 is equal to negative 1 as well. Now, if you wanted to go through the process, you can make it a fraction and flip it, but you're still going to end up with negative 1. Remember, a reciprocal, you have to be able to multiply that number. If we multiply these two numbers, we end up with 1. Okay, and that's by definition a reciprocal. It's what would you multiply it by to get 1. Alright, here we're back to something that's not going to be on one of the axes. Okay, so we have the sine of 2 pi over 3. So let's go figure out, going back to our little, where we drew our diagram of the unit circle and got our reference angles. Let's go see when we have the denominator of 3, what's the possibility of our y value. So if we go back to here, okay, our y value when we have the denominator of 3 is the square root of 3 over 2. So for this one, we know that it's going to be the square root of 3 over 2, but we have to figure out what quadrant we're in. Now if I do 2 divided by 3, I get 0.66. Okay? So let's decide what quadrant that falls in. Well, I know this is 0.5. If I convert that fraction to a decimal, it's 0.5. This is 1. So it's going to be somewhere in here. So since it's in the second quadrant, we know all students, sine's positive, so that's our answer. Now, when I say sine is positive, it's also sine and cosecant. Okay, so the inverse is positive as well. I'll finish up the rest of it on the next video.